Hey everyone, welcome to this introductory video for tool-assisted speedrunning Celeste. In this video we're going to cover the format of a TAS input file and some useful commands you can use there. We're going to get a basic understanding of the Celeste movement engine and how it interfaces with Celeste Studio. And we're going to talk about the specific mechanics of dashing, jumping, and grabbing and the related tech with some examples. Then finally we're going to tie it all together by making a core one-up TAS. The format of an input file is pretty straightforward. On the left you've got however many frames you want your input to last for, and on the right you've got whatever inputs you want to happen on those frames. So for instance, 99R is going to send Madeline to the right for 99 frames, 99RJ is going to make her jump to the right for 99 frames, and 99RJX will make her dash jump to the right. There's 14 letters corresponding to inputs. You've got L, R, U, D, corresponding to left, right, up, and down, your 4 cardinal directions. You can also do F for analog input, followed by whatever angle you want it to take. Mostly you're going to see this being used for feathers, because feathers have angles in between the regular directions. By default, the angle is 0, which corresponds to straight up. If we do 90, that's going to take us over to the right. If we do 180, that's going to go straight down, and 270 is over to the left, and then of course every angle in between that you can think of. We've got our jump button, J, and then we've also got a secondary jump button, K, which is mainly going to be used for stuff like optimal wall climbing, where you don't want to let go of jump at all. You'll do 12 frames of jump and then 12 frames of K, so you get another jump without having to release the jump button, and then repeat. We've got our dash button, X, because I believe X is the default dash button for controller. And then we've got our secondary dash button, C, which I believe is because X and C are adjacent on the keyboard, just like J and K are adjacent on the keyboard. Makes sense. Mostly you're going to see C being used for stuff like dashing twice in quick succession. So if I do dash up for 15 frames and then immediately dash to the right, you'd see something like this. But the other thing that C is useful for is if you're in a room with something that's interactable, like for instance binoculars. If I try and do X in this location, it'll interact with the binoculars instead of dashing. So instead I use C, which is a non-interaction button. We've got G, obviously, which is our grab button. And then we get into some of the weirder buttons. We've got S for start, which opens up the pause menu. Mostly you're going to see this being used for quick retries. So we're going to do 1 S, 1 down, which takes us to the retry button, and then 1 down J, because J is also the confirm button. And then, interesting fact, if you retry and then press confirm again, it'll speed up the restart process. But we can't press it the frame after because that'll just count as holding it down. So instead what we do is we've got this O button, which is a secondary confirm button, so that we can retry and then confirm on the very next frame and get an optimal retry in that way. The last key that I'm going to talk about is Q, which used to be used for quick restarts. You can see if I hit Q, that brings up the restart chapter button, or the restart chapter menu. Most often, the old TASes, you would see the restart, this is a comment by the way, if you put hashtag in front of any line, it'll just ignore it. You would see 1 Q, and then 1 J to select to confirm it, and then 31 would launch the animation, and then you restart in this case, level 04, and then the TAS would continue from here. Nowadays, what you're going to see more often is the console load restart. So if you're familiar with the developer console that you can get by hitting the tilde key or the backtick key, if you type in, for instance, load 7, that'll load me into 7A. If I do hard 7, that'll load me into 7B. And if I do RMX27, that'll load me into 7C. And you could do a similar thing with the TAS tools. If I type console RMX2 7, and then just one frame after that, that'll go ahead and load me straight into 7C, and I don't have to muck about with the restart chapter. And this is generally better because restart chapter will not work, for instance, when you're dead. I'm hitting the restart chapter button and nothing's happening, which can make it cumbersome to restart your TASes. But console load will always work. If I die and console load sends me straight back to the beginning. So more often than not, this is the sort of thing that you're going to be using, console RMX2 or console load 7. And you always want to have one frame after it because console load will just do weird things with the frame after it. It's better to just have an empty frame where nothing happens there. Other than that, there's breakpoints, which we're going to touch on a little bit later, but essentially this allows you to jump anywhere into your task that you want without having to watch the entire thing from the beginning. And there's also the read command, which allows you to read from another file. Again, we'll touch on this a little bit later in the video. Before we can talk about movement, we need to discuss a little how Studio interfaces with Celeste. So first of all, it is possible to edit a task while it's running. If I go ahead and decide that I want to input a jump here, we can see by that number in the top right that 68 frames have elapsed in the current input. So immediately after that, I'll go ahead and input a jump, and as soon as I frame advance, there it is. It's important that you either frame advance or continually frame advance after editing a task. If I try and input a down right dash here and then immediately resume playback, you can see that nothing happens until I either frame advance in some capacity. You will also notice that the info bar down there is being continually updated even though I'm not playing a task right now. That's useful for several reasons, one of which being that you can determine where Madeline's position is even when a task is not playing. Madeline's position corresponds to the bottom middle of her feet, and for this I'm going to turn on hitboxes and simplified graphics. You can see that Madeline's actually got two hitboxes. She's got a green hurt box, which is what she uses for colliding with spikes, spinners, and other deadly sharp things that can kill her. And then 2 pixels added onto the bottom of that red rectangle that she's currently standing on, that corresponds to her hitbox, and that's what she uses for colliding with walls and other solid objects. So movement. Madeline moves every single frame based upon her speed. At the end of every frame, her hitbox gets updated, her hurt box gets updated and tested for collisions with deadly things, meaning that if you are going fast enough, you can actually get her hurt box to teleport through deadly objects. The same cannot be said of solid walls because her hitbox is updated every single pixel. Every frame, her hitbox will move first horizontally and then vertically 1 pixel at a time. So if I were to, for instance, go over here and input an up left dash, you can see it looks like, just based on her trajectory, that she will be able to make it around this corner. But because she moves horizontally first, the very bottom of her hitbox, that red pixel down there, is going to smack into the wall, and then she's going to move vertically. So you can see that her speed does indeed get set to 0, meaning that she's bonked into the wall. If we go on over here now and input an up right dash, similar sort of circumstance, she's right next to a wall. It looks like she's going to collide with this one. However, keep in mind that she moves horizontally first and then vertically, so she'll move horizontally far enough to get away from the wall before moving vertically around it. No problem whatsoever. Speaking of moving around corners, there is an interesting thing that Celeste likes to do when you come into contact with certain corners, and that's that it likes to eject you out of them. So you can see right now we're within 4 pixels of the edge of this corner. 4 pixels or half a tile, and as soon as we hit it, Madeline gets popped out to the right. And this works as long as you're moving up into a corner, as long as you're not moving towards it. You need to either be moving away or moving straight vertically. You can see here, if I move even the slightest bit towards the corner, Then Madeline bonks into it and she does not get ejected. We've got a similar sort of thing with downwards corners, however this time we cannot simply fall into them, we need to be actually dashing downwards into one. So you can see there, as long as she's within 4 pixels of the bottom corner, she gets pushed around it. This one again, we need to make sure, in addition to dashing, that we are not traveling towards the corner. Moving directly downwards is fine, and moving away from it is fine. So you can see here, by the time she moves horizontally, she'll be far enough to the right that she'll be able to be within 4 pixels of this corner, and that's going to cause her to be popped out to the side. If, however, I were to do a down left dash from here, by the time she moves horizontally, she's going to be within 4 pixels of the corner, but because she's moving towards it, she lands up on the ground. Similar thing with moving left and right into corners. However, this time, in addition to dashing, we need to be moving horizontally. We cannot dash up left into a corner or we'll bonk, and same thing with down right. We need to dash straight to the right in order to clip around this, like so. And same thing with ceilings. As long as we're within 4 pixels or half a tile from the ceiling, we'll be able to clip down underneath it. It's almost always going to be 4 pixels or half a tile, except for dashing straight up into a corner, which for some reason allows you to be 5 tiles away, probably to make wall bounces a little more lenient. So basically what this means is that whenever you're rounding a corner, most of the times, it's going to be a little more lenient than you imagine. And it's particularly useful in instances where you want to do, in this instance, a 4-tile wall jump, similar to the end of the dashless golden. We can see that as long as we're within 4 tiles of this corner, we're going to just be able to squeeze around it, which you might not be able to do normally. So now we're going to talk about speed and time. And there's 2 timers that can be reasonably used for Celeste. There's the frame timer, which is in the top left corner of the studio info bar, and is the closest thing we have to RTA, or real-time attack. And then there's, of course, the in-game time, which you can see both in the chapter timer in-game, and also the timer in the studio info bar. These are different, it's important to note, for a couple of reasons. For one, the in-game timer runs slightly fast, because a frame is 1/60th of a second, but 1 frame of in-game time is 0.017 seconds. But more importantly, certain actions will cause the in-game timer to freeze. So dashing, collecting a refill crystal, and destroying a breakable block, all 3 of those will cause the in-game timer to freeze for 3 frames. So for the most part, you're going to be timing TASes using in-game time. If you're comparing routes, especially ones that use a different number of dashes, use the in-game time to compare the end results. So now I'm going to throw some values for speed up on screen. The units for speed is 1 pixel per second, so 60 speed corresponds to 1 pixel per frame. Most of these values you don't need to know, but I'm going to point out a couple things that are useful to keep in mind. For starters, your base walking speed, whether you're on the ground or in the air, is 90. If you're traveling faster than that, then you're going to be slowing down on every single frame. Let's say you're moving very fast to the right. It doesn't matter whether you're holding nothing or whether you're holding left. Both of them will slow you down by equal amounts. So if you're trying to manipulate something, pick one or the other. Usually I like to choose left because it makes it more visually obvious that you're manipulating on that frame. Ducking on the ground is a sort of in-between speed between holding right and holding left or holding nothing. However, when you're ducking on the ground, you cannot hold left or right. They will not influence your speed in any way. Vertically, we've got gravity adding plus 15 to your speed every single frame, except when you're 1 pixel above the ground where gravity does not apply. If you're holding jump while the absolute value of your speed is less than 45, then gravity will be cut in half. However, as soon as your speed gets over 45, then gravity goes immediately back to being 15. And there is also no need to hold fast fall when your speed is below 160. It does not do you any good. Now we're going to talk about the movement tech in Celeste, and I'm going to throw some charts up on screen that show you the general frame counts you can expect for a lot of this stuff. If you're already familiar with the advanced movement tech in Celeste and how it works on the back end, this is probably all you need in order to get started. However, we're going to go ahead and run through some examples, and our first example is going to be on the Glyph custom map made by Beefy Uncle. And we're going to go ahead and load up into the second checkpoint of this map. So the first thing we want to do is input a restart, obviously. There's two ways to do this. We can load this checkpoint manually and then do it the old-fashioned way. Or we can use our new console load. So I'm going to go ahead and open up the debug console. And we can see in the top left, we've got our ID, which is 11, and our SID, which is Beefy Uncle Tor Map 1. And we're going to be using the SID because the ID can change depending on what custom maps you have installed, how many of them, and what order they get loaded in. And then after the SID, in our console load command, we're going to add the room that we want to load into. And this is particularly powerful because even if I run this command from, let's say, back in the file selection on Celeste, it'll still drop me straight where I want to be. So after this, I'm going to add our current room name, which is just in general good practice. This is a comment, so this won't get executed. It's just there to tell us which room we're currently in, which is useful for a number of reasons, one of which you'll see later, and one of which is just so that if you have a large TAS, you can tell quickly which room is where. After that, I'm going to put a breakpoint, which just tells the TAS to run until that point and then stop. And after that, I'm going to put an arbitrary number of frames. And we want to figure out how many frames Madeline is... how many frames it takes her to load in to get control. So I'm just going to go forward, and I'm watching the text down in the bottom left of Studio where it says no control paused. I'm waiting until that doesn't say paused anymore. So if we go ahead, bup, 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 and right there is our first frame of input. So we've got 36 frames of loading and then one frame that we'll be able to input. So I'm going to go ahead and move my breakpoint up, and now we need to figure out how we want to get over to this platform here. The first obvious choice is just an upright dash, but that gets us significantly too high, and we spend a lot of time waiting, falling down to land on the platform. So let's try something else. How about a hyper? And if you're familiar with hypers just from speedrunning or playing the seasides, you may think, oh, well, we'll just input one frame of a downright dash and then hyper to the right, which works, but if you'll notice, the next 3 frames after this dash are all pause frames. So it makes a lot more sense to say 4 frames of dash and then our hyper out of that. And that's actually a bit too low, so let's do a super instead. Similar sort of thing. We're going to do for our X this time. 1 frame to dash, 3 frames where we're paused, and then the actual super itself. And we're going to go ahead, let me just check my notes, take this up 6 frames, and then 7 to the right. And you'll see this 7 pop up a lot in TASing when you're trying to land on a corner, because this is the number of frames out of a typical jump, wall jump, etc. that it'll take for you to land on the ground. You can see if I wait 6 frames, even though I am currently on the ground, my speed is still -15. I'm not moving downwards yet, so it doesn't count as landing on the ground. So even if I try and jump here, nothing will happen. I need to wait 7 frames in order for my speed to go down to 0 in order to properly land on the ground. So those are a couple pretty straightforward options, but we can do better. We can start with a jump, which I believe is 9. Yes, it is. And then we're going to dash to the right. So there's our jump. We're going to wait till we get over the top of this, dash to the right. And as soon as we're on the ground, we're going to go ahead and jump this away. And unfortunately, because it's only been 9 frames in the dash, you can see here 9 frames, when we jump, we don't actually get our dash back. We need our 10th frame of the dash or later to be on the ground in order to get our dash back. So if I were to change this to 10, now we get our dash back. And there's a couple more things to mention here. One, we can start this dash a lot earlier because of the 4 pixels that allow us to clip up onto this corner. That also gives us our perfect 10, so we get our dash back. We can also make this a demo dash. You can see right now, out of this dash, we're getting 260 speed because it counts as an extended super. But by demo dashing, we can turn it into an extended hyper. And the way a demo dash works is, on the first frame of the dash, so right here, we're going to dash downwards. The first frame of the dash sets our hitbox, and then the 5th frame of the dash, so 4 frames later, is going to set our direction. So 1, 2, 3, 4, and now we're moving to the right. And you can demo dash in any upwards direction. You can demo dash, in fact, let me move this breakpoint up to here. You can demo dash up to the right, you can demo dash straight up. As long as it's not a downwards direction, you can dash with a crouched hitbox. And what dashing with this crouched hitbox allows us to do is it allows us to get an extended hyper off of this platform. You can see now our speed is 325 instead of 260. So now it may seem like at this point, well, we just got an extended hyper. Of course we're going to ultra out of it. If I try and input a downright dash at this point, nothing's coming out. And why is that? Well, if you look in the bottom of Studio down there, you can see a dash timer. And our dash timer is constantly counting down. And it's not until this timer reaches, until the timer disappears completely, that we're able to dash again. And this will always happen after 15 frames. So you can see 4 frames from that, plus up to 10 frames in order to get our extended hyper. 1 frame for the jump, 4 frames after that, that gives us 15 frames total. And now we're able to dash down to the right again. Every time we dash down right, as soon as we land on the ground after that, doesn't matter what happens in between, our speed is going to get multiplied by 1.2. And that's what's considered an ultra. So if you see here, our speed right before hitting the ground was in the 260 range. And as soon as we hit the ground, it bumps up to 322. It's interesting to note that if you happen to just barely reach the ground without actually colliding with it, so in this case, we're 1 pixel above the ground. We haven't hit it yet, so we haven't got the speed boost. But because we are 1 pixel out of the ground, we can still jump out of it. And that's something important to keep in mind, because now our speed is less than 300 again. We didn't actually get the ultra that we were going for. You need to make sure that you actually land on the ground, that Madeline actually runs into it in order to get the speed boost. You cannot simply be a pixel above the ground. So there's our ultra, there's our jump, and now I'm going to talk about what's called a grounded ultra. So if I now input another downright dash, you can see as soon as she lands, her speed goes all the way up to 426, and that's because, again, every time we dash down and right, our speed gets multiplied by 1.2. So grounded ultras are really useful for going fast. The unfortunate thing about them is that you cannot maintain that speed out of them. As soon as the grounded ultra ends, for the most part, your speed is immediately going to get cut back to whatever the speed would be from just dashing across the ground. The only way you can maintain speed out of a dash is if you dash down right and then do not land on the ground within those 15 frames. So now this grounded ultra is going to take us into the next screen, and you can see down there it says on the bottom left of Studio, no control. That means that we're currently in a screen transition. And by and large, every screen transition in Celeste is going to be 40 frames. If there's a breakable block in the room, it'll be 43. And if there's some visual light effects, then it will be 60. But for the most part, it's going to be 40. So we're just going to go ahead and plop that in there. And wait until the no control vanishes. There it is. And we can see, once again, 40 frames right on the nose. Now we're going to go ahead and mark our next room. We can see down there, I don't even have to open up the debug console because Studio tells me down in the bottom that we are currently in room piece-000. Alright, now back to the grounded ultra. If you remember, we're currently 6 frames into a grounded ultra. A dash lasts for 15 frames. So 9 frames later, what do you think is going to happen to Madeline? Our speed is currently 427, 7, 8, and there, at the end of the dash, instantly cut back down to 160, which is the same speed we would have if we just dashed horizontally to the right and then the dash ended. We can still jump out, but this will only give us hyper momentum, only 325. So now let's talk about corner boosts. You may notice that it says down there in the info bar, wall-R, and that means that currently Madeline is close enough to the right wall that she's able to jump off of it. She's not close enough to grab it. She'd have to be 1 pixel closer to do that. But she's close enough to jump off of it. So if I go ahead and input a grab jump to the right, pay attention to her speed. Going in, it's 325. She hits the wall, and it gets set to 0. But as soon as we move past the wall, 356. And that's because every time you jump, doesn't matter if it's a B-hop, doesn't matter if it's a wall jump, as long as you're holding a direction, you'll add 40 speed in that direction. And as long as we crest the wall within 4 frames, then we'll maintain that speed. If we wait longer than that to crest the wall, so let's see, there's 1 frame against the wall, 2, 3, 4, 5. Now her speed is actually dropped to 0, because now she's finally stayed against the wall long enough for that speed to be killed. But as long as we go 1, 2, 3, 4 frames, now she keeps all of that speed out of the jump. And then we can do another corner boost on this wall. Why not? Because we're within 2 pixels of it. Corner boost out of there. Grab. Yoink. And we get another plus 40 speed. So now we're all the way up to 387. So those are the 2 main ways that you're going to be building up a lot of speed. Is ultras and chaining corner boosts. And then moving blocks. But we'll get into that in another video. So let's move on to our next example. And for this one, we're going to head on back over to the official levels and on over to Golden Ridge. And the first thing I'm going to do is I'm going to hit F6 to go ahead and open up the map viewer. And then I'm going to go find the room I want, which appears to be this one. So in the top left, you can see that's A-03. So console load 4, because Golden Ridge is chapter 4. This will work for every chapter except for the ones after epilogue, because epilogue is chapter 8, making core chapter 9, and farewell chapter 10. So console load 4, A-03, leave 1 frame after that. We're going to annotate our room name. And then I happen to know that this one takes 36 frames to load in as well. So we go ahead and run that. And our goal here is just going to be to get into that bubble down there in the bottom right. So the first obvious thing to try is an extended hyper. Recall that after 15 frames, so 13, 14, 15, our speed gets set back to 160. And trying to jump out of this, we just get a regular jump. We do not get a hyper. So 14 frames is going to be the maximum extended hyper that we can get. And notice also that our speed here is 203.65, which seems like a kind of weird number until you realize that a regular diagonal dash will give us 169.71, which is essentially just a speed of 240 at a 45-degree angle, and then taking that speed down every time a down right dash hits the ground, our speed gets multiplied by 1.2, and that's where we get our 203 from. We can go a little bit faster anytime we're extended hypering on flat ground like this by instead doing a demo dash to the right. So 4 frames of down, 3 of which are paused, and then just a straight right dash gives us a speed of 240, and we get hyper speed out of it. So this hyper is a bit too high. Even if we didn't hit that bubble, we would have definitely hit the wall. So let's go ahead and make that 4 instead. I'm going to move my breakpoint up. And that's we are still gonna hit the wall, but because we move past it within 4 frames, we get our speed back immediately afterwards. And let's just see how far we can get with this. That looks like about as low as we're gonna go. And then throw an upright dash in there. Not quite enough to make it to the bubble. And that's because we're not controlling our jump height effectively. So I'm going to show you right now. This is technically a hyper, but it behaves the same as a jump in that the first 4 frames, up to 12, we're going at the same speed upwards. So in this case, negative 52.5. For a jump, it would be negative 105. But as long as we're holding the jump button, that's the speed we're getting. And then as soon as we release it, every frame, 15 is added to that speed, which makes us rapidly plummet downwards. So how to fix this? Well, if we let go of jump earlier, so that we get a low jump, and then immediately after letting go, we re-grab jump in midair. Now, because our speed is less, or the absolute value of our speed is less than 45, holding jump in midair is going to cause us to not gain 15 every frame, but rather 7.5, halving our effective gravity and making the trajectory of our jump a lot more fall a lot less quickly, I suppose. So now let's go ahead and see how this does. And yes, indeed, we do indeed make it up into the bubble with room to spare. However, as with the previous example, we can do better, and we can do that with a hyper bunny hop. And I know what you're thinking. A hyper bunny hop, won't that be even higher than a regular extended hyper? Which, yes indeed it will, as you can see here. But the one advantage we have from a hyper bunny hop is that we can do it from beneath the platform. So if you'll notice on this frame right here, I haven't landed on the ground yet. I still have a positive speed, but I can certainly jump from this frame, and I do indeed get my dash back here as well. And I get put into coyote time, which means that as soon as I leave this, I will still be able to jump in midair for up to 5 frames. So 1, 2, 3, 4, 5. You can see I'm now pretty much a full tile beneath the platform and out in midair. And when I input a jump, well, we still hit the wall. which is where the ability, the one other advantage this has over extended hypering in this circumstance is that we can do a duck jump. We can do a ducking hyper bunny hop. You cannot do a ducking extended hyper. So duck jumping is as simple as ducking on the ground and then jumping, and it works the same with a hyper bunny hop. So as soon as we're on the ground, which is 7 frames in, we're going to duck for the remaining 5. You will notice, if you're paying close attention, that this does reduce our speed just a little bit, because ducking on the ground is slower than holding right on the ground. However, it's negligible compared to the benefits. And you may be thinking, well, why don't we do 1 frame of right down and then 4 frames of right? It's because holding duck has no effect on your horizontal speed in midair. That's not entirely true, but for the most part. In this case, it doesn't matter whether we're holding down or not, because it only slows our speed down when we're on the ground. So now we're going to go ahead and do our jump, and we're a little bit too high to get over the wall, but that's fine because we can do 1 frame of jump and then just coast underneath it, right? Look at that, we're going to go right underneath the wall. Well, no, because unfortunately as soon as Madeline's speed becomes positive again, or 0, then she will uncrouch. And the way to deal with that is once again using a float jump. So we're going to let go of jump. We get 2 frames of -105 speed. Then we let go to start getting a low jump and then re-grab immediately. And you'll notice that re-grabbing immediately doesn't have much effect, actually, until our speed is less than -45. This is the first time we actually get the 7.5 gravity instead of the 15 gravity, which is why I generally like to do when I'm doing float jumps is to put a 5 there instead of a 1, because it makes it a lot more clear what's actually going on. And you may sometimes be wondering, well, how come when I change this to a 2 or a 3 or a 4 that it doesn't actually help me get any lower with my jump? That's why. It's because it doesn't take effect until 5 frames later, which can be useful for, among other things, subpixel manipulation. So 2 frames of -105, and then the next 5 frames don't matter because we're not traveling. Our speed is not beneath 40. As soon as it is, then we can re-grab jump and coast right underneath this ceiling, and then right up into the bubble. So now for our last example, we're going to head on over to a map that was definitely not created with the sole purpose of demonstrating some TasTech. And the first thing we're going to talk about is walls. So first of all, as long as you're within 1 pixel of a wall, you'll be able to grab onto it, but only when Madeline is moving downwards. So you can see right now our speed is -15, 0, she's not grabbing onto the wall, and there we go. After 8 frames, we finally grab onto the wall. And you'll see this 8 frames and then a grab a lot coming out of a jump. When we're up to 2 pixels away from the wall, we cannot grab onto it. However, what we can do is grab jump from it, and we can do regular jumps from it when we're up to 2 pixels away from the wall. When we're up to 4 pixels away from the wall, that is the point at which we're able to do wall bounces. And we can even climb jump out of a dash as long as it is after the dash has ended. If we try and do it during the dash, then it will just become a wall bounce. So now you may be looking at this map wondering about that big wall over there on the right. Well, we've talked about the advantages of hyper bunny hops over extended hypers. Let's talk about the advantages of extended hypers over hyper bunny hops. And you'll remember I told you that, well, dashing down to the right gives you 203 speed, while demo dashing to the right gives you 240. But that's not entirely true, because dashing down right just gives you 1.2 times whatever speed you currently have. So if you currently have a lot of speed, that's going to be the option that gets you further off of the edge. So let's take a look, and for this, I'm going to go ahead and use a fancy trick of the console load, which is loading at a specific position. So let's just go ahead and put in 5100, and then the room name, which you can see at the bottom of Studio in the info bar. 36 frames to load in. And then what I'm going to do is I'm going to do a down left dash, I'm going to do a reverse hyper, and then I'm going to do a grounded ultra to the right. So let's see. Oh, and I forgot to put the SID in there. So TasTech and then the coordinates. And now we go ahead and do that. So 14 frames down into the left. And now you'll notice I'm on the ground, but I haven't actually collided with it yet. My speed is still positive, so I won't be able to get a jump out of this. However, that's no problem. We can just add 1 to our vertical position. And now we actually do land on the ground. Being able to load into any coordinates you want makes it really easy to test things without having to bother manipulating position very precisely. For instance, right now I can see that I'm 10 frames into the dash. I want to be on the ground in order to get my dash back, but I can be a little bit closer to the right. If we look at this position, we can be 1 pixel further right, so I'll just go ahead and edit my position up here to be 1 pixel further to the right. And that's going to be the furthest extended hyper that we're able to get off of this ledge within reason. And you can see because I've got 390 speed now, I've gotten significantly far by the time I start jumping. So now we're going to have a look at getting around this wall on the right. And, well, the most obvious thing is just to dash diagonally up and around it. So let's go ahead and do that. Diagonal upright dash. And we can even jump off the wall on the other side, like so. Unfortunately, this doesn't get us quite enough height to reach the platform over there, so okay. One other thing we can try is, instead of doing a regular dash, we can do a demo dash, which means that we're able to dash earlier, and when we get around the wall, our hitbox is higher. So now when we jump, well, we still don't reach the platform, but we got closer, which is the important thing. So how are we going to reach this platform? Well, it's pretty clear that we need to somehow get a wall bounce off the other side. And I'll let you know right now that if you just try sliding down the left side of the wall and try to wall bounce on the right, it's not going to get far enough to reach, which is where we get into a very interesting bit of tech that is ceiling pops. So let's have a look at this. So here I am, right here. I'm 1 pixel below the wall, and whoa, what happened there? I actually managed to grab onto it. Now, a couple things happened here. For one, we were 1 pixel below the wall and able to grab onto it. And that's just something you can do. The game has a little bit of leniency when it comes to grabbing walls. If you're down below it, you will still be able to grab onto it. And the second thing that happened, and this is the crucial thing for ceiling pops, is that I grabbed onto the wall. By grabbing onto the wall, you can see that my speed went from, here I've got 160 speed, it went down to 32. But that 32 speed was enough to push me 1 pixel lower underneath the wall. So now the game thinks I'm still grabbing onto the wall, even though I've technically fallen a little bit beneath it. And what that's going to allow us to do is it's going to allow us to jump off of it from underneath. And this jump, which is called a ceiling pop, is going to get us just far enough. Don't worry about this 2 right down, that's just some subpixel manipulation. Is going to get us just far enough to make it around the wall. And remember, as long as we move to the right, we're within 4 pixels of the edge, we're going to pop around it. And then this 15 up X 5R, that's pretty much the maximum you can go and still get a wall bounce. Like so. So at this point the video is pretty much done. All the useful information has been explained, but I'm still going to do one last thing in this video, which is make a core 1-up TAS from start to finish. Why a core 1-up TAS, you may ask? Well, it's because I can steal pretty much everything from the existing core ARB TAS, which is generally what you want to do while TASing, is steal as much as you can from existing inputs. And I'm going to be stealing a lot of this from my notes, just to expedite the process. Once we've grabbed the golden berry, we're going to go ahead and do a hyper bunny hop on over to the right. And hyper bunny hops, for the most part, are going to be 7 frames, unless you're doing some subpixel shenanigans. And now at this point, what I'd like to do is sync this to the existing TAS. So, first thing I'm going to do is I'm going to save this, Control-Shift-S, and then I'm going to open up the existing core TAS. And now that I've gotten to the same room, we're going to see where would be a good point to sync it. You will notice that right here, the TAS does a double corner boost, which is great because that sets our horizontal speed back to 0 and makes it really easy to sync. So what I'd like to do is sync it at this point right here. So I'm going to put in a breakpoint and see at the end of this input, we're at approximately -205 for our Y position. And then what I'm going to do is I'm just going to grab all the inputs for the end of this room, copy that, open up our TAS, and plop them in. And now we're going to try and get them to line up. So we're looking for a position of about 205, and 204.19, that's pretty close. So let's try that and see if it works, and if it doesn't, then we can go one more frame. So there we go, we get the double corner boost, and we do indeed land on the ground after 14 frames. So our horizontal's fine, our vertical's fine, this should sync no problem. And indeed it does. And now that we reach the end of the room, you may think, well, the logical next step is to grab all the inputs for the core TAS for the next 50 rooms and plonk them in here. But we can do something else. We've got a fancy read command present in Studio, and in CelesteTAS, I should say, that allows us to read straight from the 8S core TAS until whatever point we want. So we're going to start at, let's see, what is the next room here? It's A-01. And do you remember those, the comments in our TAS file, these room names? These are what's going to tell us where to read from and where to read to. So let's go ahead and open up the core TAS and see where we want to stop reading. And it looks like right here in D-07 is where we're going to have our first issue, because this battle and boost is going to force us to collect one of the berries. So we don't want that. And you will notice we do also collect a berry right there from that dash. So let's go ahead and grab both rooms, D-07 and D-08, and bring them on over to our TAS. And it should be pretty clear then that what we want to do is read from level A-01 to level D-07. So now when I run this, if I start from here and launch the TAS, it's going to read the end of my inputs, and then it's going to start reading from the existing TAS. And then when it hits the end, it's going to jump right back into our inputs once more. This section of D-07 is fine. Ideally, we want to get past Battlein without interacting with her. So let's see how far it's going to be to get a wall bounce off of there. Looks like about 31 frames should be enough. And I've already tested this before, but I happen to know that 2 frames to the left, and then I can begin going back to the right, and that'll clip me around the corner. We're going to wait until we get back against the wall, which looks like right there. So 21. Jump to the right. 1, 2, 3. And we're still 2 frames away from the wall, so I can still jump from here. And watch my speed during this section, because you'll see that it never changes from -105. And that's what we want. As long as our speed is constantly -105, then we are climbing this section optimally, which, as long as all of your jump inputs last at most 12 frames, will be the case. So in this case, we reach the wall on the other side within 11 frames, which is perfect because it allows us to jump back to the right once more. And doesn't this look familiar? We're at this corner again, where we were just 8 tiles below us. So we might as well just, because this whole section is pretty much a repeat, we can copy these inputs. Put a breakpoint in there. We can copy these inputs and just repeat them ad nauseum. So let's see if that works. Jump, jump, yep. Hit the wall, yep, jump off of that, very good. Keep going. And, uh-oh, we've got a slight problem here. We didn't quite get high enough. We were losing a little bit of height over the course of these inputs. So let's just add 1 more frame to this guy, and that should be enough to get us up to where we need to be. And indeed it is. There we go. And let's just make sure the rest works out all right, which indeed it does. So now we enter this screen. The screen transition ends after 40 frames, and we'd like to find a point to sync this here. So let's go ahead and open up the core TAS once more, and go on down to this point. It's level D-08, here we are, and let's see what we're looking at here. So the dash, that's where we collect the berry, that's what we want to avoid. The dash breaks the block, and then we get another downright dash that goes until position 7134. So let's just grab that, open up our TAS, and that would be, we're going to get rid of these inputs, and ideally we want to be at 7134, dashing down and to the right. So let's try and make that happen. Do 1 grab jump, and because we still have speed, we haven't hit the wall yet, we are going to be able to fit another grab jump in here to get a little bit more speed off of that. Gonna go until we hit the ground there, and then jump to the right again. Three frames. And this time, we do actually hit the wall, so even though we're going to get the speed from the first corner boost, which is going to take us from 121 to about 160, even if we do another corner boost here, we are not going to get the extra speed from it. Yeah, you can see only 152 and not closer to 180. So we're going to go again until that lands. This one is pretty obviously not going to be able to get a double corner boost because we're so close to the wall. I could spend time trying to manipulate the pixels a bit better, but it's not really worth it for just a demonstration. Now we're going to jump to the right, and I can dash right here, but again, unfortunately doing this because I'm within 2 pixels of the ground, Madeline will snap back down to it and collect the berry. So ideally we need to be higher than 2 pixels above the ground when we do this dash, and it looks like 5 frames of jump will be just enough to make that happen. So we're going to break the block, and then 3 frames, 1, 2, 3 of freeze time, And then we're going to dash down and to the right. And remember, we're looking to get to position 7134. So down we go. 7130, not quite there yet. There we are, 7134. So we're going to put an 8 in there. I don't remember the subpixels, but let's just see if this syncs up. Which it does indeed seem to do, at least for a little bit, until we get here. And then all of a sudden, oh no, what went wrong? Well, let's have a look. So we're at this 14R down X in our TAS, and if we open up the existing core TAS and go to the same point, you can see it hits the bumper perfectly at the edge to squeak around and make it to this, whereas because we entered the room differently, we didn't take the battle in boost, the bumper's on a slightly different cycle, so that's why the sync didn't work. So let's find a new point to sync, and this looks to be a pretty good one. We've got 90 speed, which is our base walk speed, so we don't have to spend a bunch of time manipulating the speed in weird ways. We've got a double corner boost, so we smack against the wall. That's going to reset our horizontal subpixels. And then we smack against the ceiling as well, so that's going to reset our vertical subpixels. So this looks like a pretty nice sync point to me. So going back into our TAS, we're going to find out where that is, and it looks to be right here, these two, this double corner boost into the wall. So let's go ahead and see exactly where we want that to be. And it looks to be about -7394. The first thing we need to do is hit the bumper correctly, and from my experimentation I found that happened after 14 right down X, and then a 16 right jump. Didn't get it quite as far to the right as the other TAS, but it works well enough to get up onto the platform. And then we're going to do a couple jumps. And then we're just going to walk to the right just far enough to get to the edge of the block. And then stop there. And again, all of this stuff I'm just reading from my notes because I can't be bothered to TAS it in real time. Okay, so now after 20 frames we're going to jump off the block, and we're going to wait until we get to the position that we're looking for, this 7394, which happens right about there, 7395, and we're in the perfect position to do a double corner boost off of this wall. And this should just automatically sync it up if we've done everything correctly. So there's one jump, there's another jump, and oh no, unfortunately we were a little bit too high, but that's fine. All we need to do is make this jump just a little bit lower, and that should fix things up nicely. And indeed, there we go. From here on out, the TAS syncs up perfectly. So now once again, we're going to start reading from the existing TAS. And now we're going to go back and figure out what's the next point that we need to start editing. And it appears to be right here at level D-11. Dashing into this room unfortunately collects a berry, so we need to take care of that. So let's go ahead and grab D-11. And the very next level is the end of the map, so let's grab that one as well. And then we're going to read from level D-09 to level D-11. So when I put a breakpoint in here, we should be, yes, perfectly where we want to be, and we've got our 6 berries behind us. So after a few too many frames on the ground, one of the berries gets collected. We're going to have to fix that, but first let's figure out where we want to sync it back up again. And it looks like landing on this block is a pretty nice spot. So I'm going to go ahead and break this input up into 2. 39 becomes 20 and 19. And after the 20, we're at position 12, 758. And our speed is 52. And that should be enough to get a pretty close approximation to the sync. So let's go ahead The first issue is that we're on the ground for too many frames. I know by trial and error that 1 frame is enough, and then any more than that will collect the berry. And then from here we're going to try and figure out, let's start with the horizontal position. We'd like to get to this position with a speed of 52. And just by trial and erroring numbers, I believe it was 22 that did it. And yes, indeed, you can see that we're at position 12,759, which is close enough, and our speed is 49, which again is close enough. We're a little further to the right, but we're also moving a little more slowly. So that's about the best I can be bothered to get it. And then we just need to make sure that we land on the core block on this frame, which again just requires figuring out how many frames we need to hold jump for. And in this case, it turns out to be 11. So that's going to cause us to land right on the core block with the correct position and the correct speed. And then all we need to do is check whether or not this does what we want it to. So running the existing TAS, there it is, and yes indeed, we are going to get a corner boost off of this block, which is exactly what we were looking for. Our speed could be a little bit different because we were slightly off on the core block, but just from running the TAS, it appears to not be an issue. So now the last spot we need to take a look at is getting the 1-up, obviously. So I'm going to go ahead and go on down to space. First, we need to figure out where we actually collect the golden berry, and it appears to be this trigger right here. You can see causes us to collect it. This sort of red rectangle in this area, I'm guessing, is the collection trigger. So ideally, we want to collect all 5 berries and then enter this trigger. So let's go ahead and start with a demo dash to the right. That's going to cause us to slide along the ground and hopefully collect one of the berries. You can see that we've got a berry timer down in the bottom of Studio as well. And we're just going to wait for that to hit 8. There it is, it hit 8, which means that now I can safely jump out of this and still collect the berry. And there it is, you can hear the berry collection sound. Now we're going to land on the ground again, get a little bit more speed. I'm going to do 1 grounded ultra, because that's what I found I can get away with, and then just walk straight to the right into the trigger. So there we go, there's the second berry gets collected, there's the third, there's the fourth, there's the 5th, and the 1-up. And that's it. Our task is complete, and we can go ahead and send it on out into the world. I hope you guys learned something from this video. If you've got any questions, feel free to leave them in the comments below. Maybe I'll make future videos on some of those topics. And until then, happy tassing!